All right, we are going to be solving compound inequalities today. So, what is a compound inequality? An inequality that combines two inequalities using either an or an and. So, the big difference here is if you look at these, it says an or statement, in order to be a solution, the answer must satisfy either one of the inequalities. On an and statement, in order to be a solution, the answer must satisfy both inequalities. What I like to kind of equate this to is think about like real life a little bit. If your parents said to you, hey, you can go out with your friends if you do the dishes or vacuum the carpet. Okay, so with that situation, you can either do the dishes and be allowed to go out, or you can vacuum and then go out. You don't have to do both. Compared to a statement of your parents saying, in order to go out with your friends, you need to do the dishes and vacuum. Now, all of a sudden, you have to do both to get to go out with your friends. The same situation is going on here with an or and an and statement. With an or statement, what that's basically saying is you've got to complete one or the other. With an and statement, you have to satisfy both, have to be true in order. Now, typically, an or statement is written like this, where it'll say an inequality or another inequality. Now, when you graph those, you solve them just like what we've always been doing, like we did with one-step, two-step, multi-step. But then when we graph them, the difference is, if you look, you get to carry everything together. Anything that satisfies the first, anything that satisfies the second. So if you look at this, typically what you're going to see is it'll be a point going to the right, a point going to the left, and there'll be a gap between those 2 points. With an and statement, there are two ways of writing it. One way that you see is you'll see an inequality and another inequality. Or the second way is you'll see it kind of all smushed together here. Now, the way that is read is if you take this middle part and then you're going to separate it and put it with both of them. So the way that's read is -5 is less than x plus 3, and x plus 3 is less than or equal to -6. So that's another way that we write those and statements. Now, when you graph the solution, remember that in order to be an and statement, it has to satisfy both of those inequalities. So when you go to graph them, typically what you're going to see is a point on the right, a point on the left, and then the shaded region, the part that is overlapping, would be in the middle of those two. And from there, that is where you would find a value that would satisfy both of those inequalities. Now, the steps to solving a compound inequality is very similar to what we've been doing. So the first thing you're going to do is you're simply going to solve the inequality using the steps we've already practiced and learned from one-step, two-step, multi-step. Remember that when you solve an inequality, if you multiply or divide both sides by a negative, it flips the inequality symbol. Then the big difference is when you get to looking at what the word is. Is it an or statement or an and statement? So when we go to graph, that's the big difference. We start looking at that word closely. Because then what it says is, if it's an or statement, you get everything on the graph from both of those inequalities. If it's an and statement, you get the part that is overlapping. Okay? So let's take a look at these. Let's give it a shot. Now, most of these are going to be pretty typical ones. I will show you a couple special ones at the end. Okay, so let's start to solve. So here we would add 4 to both sides. And that's going to get us x is less than -9. Or, and here I would divide by 4 to both sides. And that's going to get me x is greater than or equal to 2. So now when I come down here, is -9, 0, and 2. It says x is less than -9, so it'd be shaded to the left. It also says that x is greater than or equal to +2, so it'd be a solid circle shade to the right. Okay, and that's your solution. So on the second one, we'd -5 from both sides. That's going to get me negative 9x is less than or equal to negative 63. At that, we're going to divide by negative 9. So x is greater than or equal to 7. Or, then over here, I'm going to minus 7 from both sides. 10x is less than negative 10. I'm going to divide by 10, so x is less than negative 1. So negative 1, 0, and 7 says x is less than negative 1, so it'd be here. X is greater than or equal to 7, and it would look like that. So that's how we solve an OR statement. Let's try one more. So I come in here, I'm going to minus 3. That's going to get me 4n is greater than 8. I'm going to divide that by 4. So n is greater than 2. Or I'm going to minus 5 from both sides. And that's going to get me 8n is less than or equal to negative 48. I'm going to divide by 8. So n is less than or equal to negative 6. So negative 6, 0, and 2 says n is greater than 2, so open circle, shade to the right. N is less than or equal to negative 6, so close circle here, shade to the left. And that is our OR statement. Okay, let's try a couple AND statements now. So here you'll notice, remember we're trying to get x by itself, and this whole middle part goes together. So I'm going to get rid of the 8 first. I'm going to add 8. Since I'm doing it to the middle, I'm going to do it to both sides. So that gives me negative 2 is greater than or equal to x, which is greater than or equal to negative 4. So negative 4, negative 2, and 0. So on both of these, they're both equal to. So I'm going to shade those both in. Now, if I read this, this part here says x is greater than or equal to negative 4. So that means we would shade going that direction. The second one here it says that x is less than negative 2, which would start here and shade this way. So when you look, what part is overlapping? And it's this part right here in the middle, okay? So it's this part right here is what we're looking at. So when we go to graph that then, what we're simply going to do is we're going to shade the middle part. That's the part that satisfies. If I pick a number out of there and plug it in, it will make both of those true. Okay, let's continue on. Let's try another one. So here we're going to minus 6 from both sides. And that gives me negative 18 is less than negative 9x, less than or equal to 0. We're going to divide by negative 9. Now, when you divide by that negative, remember when we do that step there, that flips that inequality. So negative 2 is greater than x, which is greater than or equal to 0. So I come in here, I'm going to graph now, negative 2, 0, and 2. So think about your two pieces here. It says 2 is greater than x, so that means x, and then it would shade to the left. The second one says x is greater than or equal to 0, so it'd be a closed circle, and it would shade to the right. So where do those overlap? They overlap in that section, so we would shade it in like that. Okay, on the third one here, let's try one more. So we're going to come in, we're going to minus 5. Trying to isolate that x, we want that x to be alone. So we get negative 24 is less than or equal to 8x, less than 72. Then at that point, I'm going to divide by 8. So I get negative 3 is less than or equal to x, less than 9. So I come in, negative 3, 0, and 9. It says negative 3 is less than or equal to x, and that means x would be bigger, so it'd shade that way. And then the second one is x is less than 9, so that would shade that way. So the part that's being overlapped is in between. And that's how we would do our ors and our and statements. Now let's look at a couple special cases. So on this first one here, we start in, I'm going to add 4 to both sides. So that would get me 36 is less than 9x, which is less than negative 45. My next step is I would divide by 9. So I would get 4 is less than x less than negative 5. Now, if I go to graph this, I want you to see what's going on here. So this first one, we'll graph it in a couple colors so we can see. It says 4 is less than x. So what that means is I would have an open circle, and it says 4 is less than x, so x would be greater than 4. The second one says that x is less than negative 5, so it'd be an open circle. X is less than that, so it'd shade to the right. Now, remember, this is an and statement. That's important here because, remember, to an and statement, it's the part that's overlapping. And if you notice, there is nothing overlapping, so we would say this is a no solution answer. Okay, because nothing is overlapping there. Let's try this next one. So on this next one, I'm going to add 8 to both sides. So I get 5x is greater than 15. I'm going to divide by 5, so x is greater than 3. Or, over here, I'm going to add 8 to both sides. So I get negative 3x is greater than negative 21. I'm going to divide by negative 3. X is less than 7. So now, take a look at what happens here. We have 0, 3, and 7. Now, when you look at this, it says x is greater than 3, so it'd be an open circle and it'd shade to the right. The second one is x is less than 7, which would be an open circle, shade to the left. Now, if you look at this, as I come across, that's going to fill that dot in. And as this one comes across, it's going to fill that point in. And if you notice, this is an or, remember that, meaning I get everything from all of it. So that one would actually fill the whole graph. And what we would say is that is an all real numbers graph, meaning no matter what we plug in, it's going to work. Okay, let's try a couple other ones. So here we got a minus 7 from both sides. So we get 8x is greater than 88. I divide by 8. So x is greater than 11. Or over here, I'm going to add 5 to both sides. And that's going to give me 9x is greater than or equal to 81. Divide by 9. X is greater than or equal to 9. Now, if we think of what that graph looks like, 0, 9, 11. So the x greater than 11 would be an open circle, shade to the right. X is greater than or equal to 9 would be a closed circle, shade to the right. So when you look at that, what part, it's an or statement. So remember, we get both of everything. So what it would end up being is my graph would literally just look like this. I wouldn't take the point out from the 11 because it's filled in with the part that says x is greater than or equal to 9. So there, I don't have arrows going different directions. I just have one arrow continuing on. Okay, let's continue. Let's try another one. So I'm going to minus 4 from both sides. Oh, sorry about that. That is going, yep, that's correct, sorry. So I'm going to minus 4 from both sides. So that's going to get me 27. I'm going to divide by negative 3. So n is less than negative 9. Remember, we flipped that inequality symbol because we divided both sides by the negative. On the other side, I'm going to add 9 to both sides. And that'd give me 7n is less than negative 70. I'm then going to divide by 7. So n is less than negative 10. So if you think about what that graph looks like, at negative 9, it's an open and it's less than, so it'd be going. At negative 10, it's open, going left. So this one would be an open circle at negative 9 and going left. And that would be our solution of that, because that is an or statement. Now, if you think about it, just kind of to throw this in here, if this was an and statement, it would actually be from negative 10 over, because that's the part that's being shared. So you have many different possibilities. I can't show you everything that could happen, but there's many different little changes that could happen. Remember, an and statement is what they have in common, what they share, what they overlap. An or statement is everything from each piece you get. So you just have to take that into consideration when graphing and solving compound inequalities.